Welcome back from lunch for the next sessions on Stream 2. This section is dedicated to environment and conservation. Take 2. I'm going to introduce our speakers in a moment, but before we do, I made a bit of a mistake before lunch. I had mentioned that the recordings and the resources and the presentations, etc., would only be available for the next 7 days on the platform. That was my mistake. They will be available for several months. It is just the meeting room that's not going to be available beyond the next 7 days. So by all means, those resources will be there for a bit longer. But if you did want to make the most of the meeting feature, the next 7 days is the time in which to do that. I also just wanted to acknowledge our presenting partner, Green Collar. They've been a fantastic supporter of this event and we couldn't have held it without them, so a big thanks to Green Collar. Also, the Western Queensland Drought Committee and the NRRA, part of the government, have been fantastic sponsors. I'd also like to recognise Rangeland NRM Alliance, Bayer and NRM Regional Queensland. Okay, so to get this stream underway, I would like to introduce Heather Nealy. Heather, apart from being a fantastic and active member of the conference, she's also a postdoctoral landscape ecologist. She's based at Calparam Station in South Australia. She studies ecological restoration and the influence of grazing on native plants and animals. She's here today to talk about small mammal and reptile response in domestic livestock grazing removals after about 24 years. So please make Heather feel very welcome.
Hi everyone, my name's Heather Nealy and I'm a postdoctoral ecologist. Today I'm going to talk to you about converting rangelands to reserves and what can happen to the small mammal and reptile communities after livestock grazing is removed. I'd just like to acknowledge the first peoples of the Murray and Mallee where this study took place and where I am today, and pay my respects to their elders past, present and emerging. So this study took place on Calparam Station in South Australia, which is just inside the New South Wales and Victorian borders on the Murray River. Calparam and the neighbouring property Taylorville are both owned by the Australian Landscape Trust, which is a not-for-profit conservation organisation. And both properties are in a semi-arid system and 95% of the properties are eucalyptus mallee woodlands. Calparam was purchased and destocked in 1993 and Taylorville was a bit later in 2004. When these properties were purchased for conservation, the aim was to restore the biodiversity values, and so destocking was the first management action that took place. And you see this kind of thing happening with many conservation organisations and government when pastoral properties are acquired and are being converted to reserves. So destocking is an important first step because we know that grazing, particularly heavy grazing, can affect the soil and the structure and composition of the plant and native animal communities, and this in turn alters ecological processes. So grazing needs to be addressed to achieve long-term recovery of biodiversity. However, we know that destocking is not where management ends, and there can often be a complex legacy of impacts that need to be faced. And in some cases, even the impacts of pastoralism have actually shifted the ecosystem to an alternate state. So recovery requires more active interventions. In addition to destocking, land managers may need to manage invasive plants and animals, reinstate natural disturbance regimes, revegetate, or even reintroduce native fauna. And a big focus that we've had at Calparam and Taylorville has been controlling the total grazing pressure by other herbivores after destocking. So this includes feral goats, rabbits, also kangaroos, and the way these are controlled have been through targeted culling programs, decommissioning dams to reduce the amount of surface water available for herbivores, and in some instances fencing. So you can do all of these management actions, make all these restoration efforts, but particularly in semi-arid and arid systems, which are driven by rainfall, you often get these static periods where it looks like not much is happening and maybe you're not seeing much improvement, but you will then, in conjunction with rainfall events, get these stepped improvements. So any recovery that is likely to happen in this landscape will happen over long timeframes. The aim of our study was to examine the response of small mammals and reptiles to the removal of livestock grazing using a long-term pitfall trapping data set from the year 2000 to 2018, which corresponded with 6 to 24 years since destocking on Cowpram, in mallee eucalyptus woodlands and in casuarina vegetation communities. The pitfall trapping data has been collected annually. We're up to 21 years now, and these surveys are run by the North Cowpram Volunteer Group with support from the Australian Landscape Trust. So it's a really great opportunity for volunteers to get involved with a long-term monitoring program and also get to see some amazing animals while they're at it. All right, so I'm just showing you here a map of our survey sites. This is the northern part of Cowpram. The blue dots are the location of dams. And the reason this is important is, as everyone probably knows, grazing intensity is highest closer to watering points and decreases away from watering points. So what this means for our survey sites is that some sites close to dams were subjected to historically higher levels of grazing. And these sites also happen to be our casuarina vegetation type sites, as casuarina is found on heavier clay soils, and this is where dams are constructed. So additionally, we have sites that are further away from dams that were subjected to historically lower levels of livestock grazing, and these sites are our mallee, woodland, dune and swale sites. So whenever we're comparing the vegetation types, casuarina and mallee, we also have to be aware that this is confounded by historical grazing pressure, with casuarina having much higher levels of historical grazing and mallee lower. So we have this great annual pitfall trapping data set, but unfortunately, we didn't have any quantitative vegetation data to go along with it. So this is not uncommon with long-term animal monitoring programs, but it makes it really difficult to interpret what is happening with the animals if we don't actually have an idea of what is happening to the vegetation. So what we decided to use in the absence of on-ground vegetation measures was fractional cover. Fractional cover is similar to NDVI. It's derived from satellite imagery, and it tells us what percentage of the land surface is bare ground, green and non-green. Fractional cover is a coarse measure of ground cover, and we aim to relate fractional cover values to what was happening in the small mammal and reptile communities. I want to start by showing you the results from the fractional cover data, just to give you an idea of how the vegetation has changed since livestock was removed. So I'll take you through each figure. The first one is bare ground. Along the bottom we have time since destocking, and along here is the fractional cover values, and the mallee is in blue and the casuarina is there in red. And so in terms of bare ground, we found that bare ground was strongly negatively related to rainfall. And we also found that both in mallee and casuarina, the percentage of bare ground decreased with time since destocking. Then if we have a look at the green fractional cover, there was a positive relationship with rainfall, so the inverse of bare ground, and an overall increase in green in both habitat types with time since destocking. And the mallee had overall a higher greenness compared to casuarina. Finally, with non-green, there was no rainfall relationship, but there was an overall increase to a lesser extent with time since destocking. Casuarina was greater than Mallee overall. So just looking at these values suggests that both vegetation types are showing signs of vegetation recovery in the 18 years of data that we're looking at here. Now I want to tell you about the reptile and small mammal communities. So when we looked at the Casuarina and Mallee vegetation, we found that the fauna communities in each of these vegetation types were distinct. This is showing you a visual representation of the reptile community using a word cloud. So each word is a species, and the larger the word, the higher the relative abundance of that species. So essentially, all you need to look at here is that the Casuarina and Mallee clearly have different reptile communities. And if we then look at the mammal community as well, it's much less diverse. Both communities are dominated by the common dunnart, Spinifex marina, but you can see that the two vegetation types are also different. And when we examined how the community composition overall responded to the removal of livestock grazing, we found that it was only the Mallee fauna community that actually changed with time since destocking. We then looked at individual reptile and mammal species within each community to try and find out if there were individual species that were changing with time since destocking. What I'm going to show you here is a heat map where we have time since destocking along the bottom here, and we have animal species on the side, and green indicates an increase in abundance, and pink indicates a decrease in abundance, and the darkness of the darker the color, the greater the change. So I'm only going to show you the species that had significant relationships with time since destocking. So first of all, in the Casuarina fauna community, we only had 3 species that had a significant relationship with time since destocking. These 2 geckos actually decreased overall, and this skink increased. But the thing to note here is that in comparison to the Mallee fauna community, the response of the Casuarina fauna is the colours are quite light, whereas the Mallee is there's a lot darker colours, but also we can see there's a lot more species that are responsive to time since destocking. The Mallee reptiles here all generally had this increase with time since destocking. You can see this area of green here. And then our 2 mammal species here, the introduced house mouse and the Ningawi, actually have this green area in the middle here, which is relating to 2 years of very high rainfall in 2010 and 2011. So it seems like reptiles and mammals are responding a bit differently, and also that the Casuarina and Mallee were responding a bit differently there. So if we just look at reptiles overall, this figure here is showing the abundance of reptiles, and this is year or time since destocking. The Mallee in the blue and the Casuarina in the red. So what we're seeing here is that in the Mallee vegetation type, reptile abundance increased overall, but in Casuarina it didn't. And then in terms of reptile diversity or reptile richness, which is this number of species, the same was true. So reptile richness increased in the Mallee, but not in the Casuarina. So we found here that time since destocking was important in the Mallee, but not in the Casuarina. In both vegetation types, reptile abundance and richness responded to green fractional cover and also temperature. And then if we look at the mammals, these are the same figures with abundance here and time since destocking here. We found that there was a very slight decrease in mammals with time since destocking in both vegetation types, and this was the same in terms of mammal richness. So mammals, while they were very weakly negatively related to time since destocking, they had a very strong relationship with rainfall and green fractional cover. So to summarise the results that I've presented here today, fractional cover green and non-green increased in both vegetation types. Mallee and Casuarina had distinct fauna communities, but it was only the Mallee community that changed with time since destocking. Reptile diversity and abundance increased in the Mallee, but not in the Casuarina. And mammal responses were non-linear and driven by rainfall, more so than any of the other variables. So the conclusions that we can draw from our results are that the Mallee and Casuarina had unique fauna recovery trajectories, which is not really unexpected when you take into account that they had different historical grazing pressures. So in terms of restoration, the less degraded Mallee appears to be recovering passively from the destocking process, whereas the more degraded Casuarina sites possibly are going to require more active intervention to shift them into the desirable state. We also found that fractional cover, while it does provide a good coarse measure of vegetation cover change, it doesn't reflect the complexity of structure and composition that's really important in dictating the quality of habitat for reptiles and mammals. So destocking for conservation is not a quick fix. Management is going to be ongoing over a number of years. And due to those kind of timeframes that it actually takes in a semi-arid and arid systems for biodiversity to recover, the monitoring really needs to be over those long timeframes as well to reflect that. If you would like to read a bit more information about this, you can have a look at our article in Austral Ecology about this study. And thank you very much for listening. Feel free to email me or follow me on Twitter. Thank you.
Thank you very much for your presentation, Heather. And if you've got questions for Heather, please put them in the live Q&A. You should be well schooled in how to use that now, and we'll get to those questions at the end of the next couple of presentations. It's really important to capture those impressions and ideas now so that when Heather has her opportunity to answer, they'll be there and waiting. I'd like to introduce our next speaker, Zoe. My apologies. Our next speaker is coming up in this session is Leanne Ezzy. Lee has been at the conference this week. It's been great seeing her join you in a minute. Lee is an NRM ranger for Queensland Parks and Wildlife based in northwestern Queensland. She's taken a keen interest in fire management in arid systems and will be talking today about mosaic burning in Spinifex country. Welcome to the session, Lee.
Thank you. So I'll get right into it. Fire management in Australia's rangelands is a really challenging aspect of land management. Part of that challenge is often managing fire on one tenure, where it can sometimes be at odds with the neighbouring land use and tenure in terms of fire on the other side of the fence. But I'm going to present an example today of a really long-term burn program on a national park in Queensland's Gulf country that's reversed or interrupted a really wildfire-driven regime, and in doing so has also proven to be quite compatible with the neighbouring pastoral interests. So I'll go through just four main sort of aspects of the program that we sort of set out to achieve. So the first was developing these really diverse landscapes, really resilient landscapes across lots of temporal and spatial scales. Protecting fire-sensitive vegetation communities and species. Reducing the costs of really expensive wildfire responses and impacts. and also improving the safety of national park staff and users, as well as our neighbours in terms of that fire response as well. So I'll introduce you to Bujamala first. Bujamala National Park is up in Wine country. It's up in the Gulf on the Northern Territory, Queensland border. And it encompasses nearly 400,000 hectares of Northwest Highlands bioregion. So really vast, expansive Spinifex-dominated communities on sandstone escarpments and mudstone ranges. So a really fire-prone environment, but it's pockmarked with these really fire-sensitive communities like springs, landswood, and really extensive gallery forests that sort of run across the park in 5 main river systems that make their way out to the Gulf. So you can just get a sense of the scale of the park. It's about 100 kilometres long and 50 kilometres wide. And it's really significant biogeographically as well for a range of different species that are sort of on the eastern end of their ranges. They're sort of more typically Northern Territory and Western Australian species. Some of these are listed as rare and threatened, and many of them, including the Carpentarian grass wren and a plethora of finches, rely on really long unburnt spinifex, old growth clumps, hummocks across the landscape for their foraging and nesting requirements. But the trick is they live in this really fire-prone environment, and the very stuff they need to thrive in burns hot and frequently. And so when I say flammable and fire-prone, there are very few things that will pull up a Spinifex fire in that sort of late dry season period around October, November. In fact, the only thing that will pull up a Spinifex fire almost is younger fuel. So you can get a sense from some of these pictures of just how extensive and hot these fires can burn. And so in order for us to reduce the scale of these fires and keep that older Spinifex within the landscape, it's sort of paradoxical, but we have to burn the Spinifex ourselves early in the dry season or late in the wet season, and just create these really fine mosaics of different ages of Spinifex across the landscape that effectively sort of lock up that older Spinifex within the younger burns and sort of protect them. So it's essentially modelling what happened in the traditional economy of Aboriginal fire management, and has proven to be quite a challenge over the years. So when I talk about the sort of mosaics that we're looking at Bujamala, we're trying to achieve these really sort of different age classes of the Spinifex, really sort of distributed, on quite broad and really fine scales across the landscape. So you can see in this photo, a planned burn has sort of crept into this area. It's left some of the older Spinifex hummocks behind, but it's also extinguished on these, probably 2 or 3-year-old Spinifex hummocks around here as well. So you can see about 3 different age classes of Spinifex in those photos. So I'll just give you a quick potted history of fire at Bujamala before I go on to talk about the burn program. So ever since the park was gazetted in the mid-80s, the park was subjected to these really intense broad-scale fires every 5 years. You could almost set your calendar by it, where most of the Northwest Highlands would go up in one big event, invariably taking out neighbouring pastoral properties as well. So I'll just go through a series of maps here. The black scars are wildfires late in the dry season, and the green are just these progressive planned burns that we're laying down across the landscape on an annual basis every year. So we kicked off the 2000s with a really extensive fire. That fire was probably about 220,000 hectares in size. You can see sort of broader outside the park that it was a really big fire season for the Gulf in general. And that sort of followed a really large wet season in 2000 and 2001. And it's always been really tempting to put these large fires down to big preceding wet seasons. But what we're finding is if you've got that planned burn program in place over a really long period of time, and you've got, you know, a resilient mosaic across the landscape, the size of the wet season that you have in those lead up years shouldn't make that big a difference. And so we'd always understood as land managers what needed to be done in terms of that you know, breaking that wildfire cycle. But there was a real reticence from land managers to introduce fire after those big events. And so by the time they would invariably get to those years where you could put burns in and get the country to sort of carry fire, invariably it was too late. And you'll sort of see this over these next few years. So 2002, 3, you start to see these planned reintroduced across the landscape by parks. So come 2006, which is that sort of 5-year anniversary that I was talking about with setting your calendar, this was more or less what the park looked like in terms of that sort of breakup of landscape. But 2006 was a really massive fire event as well, that clearly that sort of lead up just wasn't enough to pull that fire up. And that was a really significant event for the park and in the park's history. It cost around $200,000 to respond to and manage. There would have been significant losses on the neighbouring pastoral properties, and also cost to biodiversity that we can't put a dollar on, or it's quite intangible, but significant nevertheless. So over these next few years, it was obviously quiet in terms of fire activity until some of those landscape burns were introduced across the park. So come 2011, there's our 5 years again. We had laid down, you know, some mosaic across the landscape. But again, in 2011, sort of October, November, it wasn't enough. And an extensive part of the northern area of the park burnt in a 200,000 hectare park. And again, the park spent just under $100,000 responding to that event. And just, yeah, really significant in terms of the risk to staff out on remote fire lines, backburning and working around machinery and aircraft. So again, we came back to the same thing as park managers. We really just need to start being really progressive and proactive about introducing fire earlier and to sort of keep going. So 2012, we still experienced some fire across the landscape. And then come 2014, we really sort of began in earnest to lay down that foundation. And you can see just the different sizes in some of these patches as well. You know, we would just, some of these patches play a role in pulling fires up, and some of them, you know, are just enough to sort of break the country up and keep that sort of older Spinifex protected and locked up. So come 2016, again, here's our 5 years. We had several fires approach the park from neighbouring properties, and it was really encouraging to see that most of those fires went out and extinguished on those planned burns of ours. So a really brilliant endorsement of the program, and for the first time, at least in the park's sort of 30-year history, where we didn't have another epic fire event. So since those sort of 2016 burns, we've then just continued to just build on that mosaic. If I have time, I'd like to come back to that 2018 fire in the northern end of the park. But in short, we haven't responded to a wildfire event now in about 9 years. And we're still seeing those wildfires in the late season, the late dry season across the park. But we expect to see those, and our aim isn't to just remove late season fires from the landscape. it's really, they play a role in the system as well. It's more about just reducing the scale of those late season fires. So over that time, we've seen a really nice trend in figures. You can just see that really sharp decline in country burnt on an annual basis since that 2011 fire. So a really steep reduction in those numbers, but also you can see that the way the early planned burns are now dominating the fire regime as well. And so they're mostly green bars, which is really promising to see. Another really cool spatial metric good to use in terms of going back to that sort of distribution of age classes that we're talking about, and just a diverse distribution, is looking at just Spinifex age across the landscape as well. So if we'd looked at Bujamala in 2009 at just the general age over sort of a 10-year age range of Spinifex, you can see just how homogenous the landscape is. Most of the park is about 4 years old, over 60%, and a lot of that is, and that is the result of that 2006 fire burning extensively across the park. And you can see there's just no diversity in that distribution graph there at all, and there's certainly none of that older growth age class of Spinifex at the other end of the graph there. So if you looked in 2011, you'd see a similar story just after that large fire. That entire sort of park has really been reset back to 1 year old. And it's really quite interesting to sort of consider the fact that these can also act as warnings to land managers. If I just go back to that graph, you know, as a land manager, if you can see that 60% of your park is about to carry fire, that's a really loud alarm bell. So if we forward through now to 2020, we can just see this fabulous map of sort of rainbow vomit across the park of just a real diverse distribution of different aged Spinifex, particularly that sort of greener and bluer classes. You can see how well they're sort of trapped and locked away in amongst those younger burns, which because Spinifex doesn't carry fire every year, is just sort of protecting them for at least the next few years. So as the country is just progressively getting broken up, it's progressively aging as well. So really exciting to see those older age classes sort of appearing in the system at this stage of the program. And it's quite tempting to think maybe some of that older stuff isn't as well represented when you look initially at those maps, but when you sort of lump them together into age classes that are really significant for biodiversity, you can see that the old Spinifex is certainly well represented. And here's a nice example, again, where a planned burn, that sort of fine green fuzz, is a 1 year old burn that's left behind these little pockets. And you can see this wildfire has sort of come in from the right-hand side of the photo and more or less extinguished on that younger fuzz and left these really nice little older hummocks in the landscape. So we've found another really great outcome to come out of the program has been a real sort of, well, certainly an improvement in neighbour relations, but also the benefits of just a really tenure-blind approach to managing fire. So we've been burning in collaboration with the Northern Land Council for many years, who manage fire on the Wainyi-Garawa block on the Northern Territory side of the park. But the rest of the park is surrounded by really productive pastoral country. So we certainly weren't too popular amongst the community. So it's really promising to just see those sorts of improvements with our neighbours. So back through those 4 points, diverse landscapes, protecting those fire-sensitive communities, shifting our program from a really reactive one that costs lots of money to one now where we're really just in a maintenance stage of spending less than $20,000 a year on aerial incendiary, improving the safety to staff. No one's responded to a wildfire out there in 9 years. So these are really significant achievements. So just in short and in closing, this is really sort of long-term test match cricket sort of stuff. Effective fire management doesn't happen in 1 or 2 years. So yeah, thanks very much.
For that presentation. We've got time for one more presentation before we then go into the Q&A part for this session. So please get your live Q&A questions into the chat box beside, so we can get straight into those after our next speaker. We've got a few in there, so that's great to see. Okay, I'd like to introduce our next speaker. Zoe Durmick is an animal nutrition scientist from Western Australia. She works on native plants as forage in the rangelands, in particular those that can help us mitigate enteric methane from ruminants and manage diseases with plant bioactivity. She's involved with the MLA Beeflinks projects, CN30 and virtual fencing, and Diet ID. I'd like to welcome her to the main stage. Welcome, Zoe.
Thank you very much. I hope you can hear me or hopefully see me. So I'm calling in from the other side of the fence from Western Australia. I'm sad I couldn't come across and meet you all, but hopefully in next couple of years we'll manage to get out and see you. So anyway, this talk is about work that we did here in Western Australia about native Pilbara plants for mine rehabilitation, but also for some other uses that we might have for these plants. So, sorry, I don't know why this is. So can you see the next slide? Yeah, I don't know why it's doing that. I'm so sorry. So so as I said, the overview, we conducted the scoping study of Pilbara native plants to meet mine rehabilitation targets, but also trying to provide some additional benefits. So Pilbara is this rangeland region just, as I said, across the fence in Western Australia. It sits around just below Kimberley, and it's rich in natural and ancient landscapes, and there is huge biodiversity, as you can see on this picture on the right. It is also rich in natural resources and industries. So it has a strong mining and agricultural, especially beef industries across. But also there's some emerging industries coming up. Now, these emerging industries are captured in this document called Pilbara Blueprint Report, mainly spelling out Pilbara as the next food for highly efficient food production, especially in beef and cropping, and becoming a supplier of this high quality food that can contribute to our food security. But let's go back to that mining, and this talk is about initially about the mining. So Pilbara mining contributes to impressive 90% of Australia mining exports, which then contributes to about 8% of our GDP. So no wonder we're holding on to it and exploring that. However, as we mentioned, or we already know, mining comes with some issues. First of all, we're severely changing the landscape. We are altering the natural environment. We're also removing soil, plants, habitats, and animal species, and then introducing some new species, including us humans, along with some pests and diseases. So obviously, this has to be fixed after the mining is ceased. We then try to rehabilitate the mine, and we are aiming to put everything back together through native restoration. However, more often than not, we end up with doing something else. We can't put everything back together like it was, so we end up using land for cropping, grazing, some other human use, or alternatively for conservation. So when we're trying this mine rehabilitation, the first question is what to plant. And our choice is ideally driven by this pre-disturbed record. What was there before? However, again, often it is more about what is available, what is cheap and can be sourced. And also, as we heard on many talks before, is what is easy to establish and grow, what will end up growing in these places. So the first issue is we are trying to put back the native plants. So seed is collected from wild. We don't have any plantations to grow seeds for rehabilitation, at least not in WA. And there is a huge demand for these seeds. There is about 10,000 abandoned mines in WA, but also this is just for mining sector, or also there's other rehabilitation efforts everywhere. So because they're collected from wild, we don't have enough seed. The seed is also of poor quality. And again, we mentioned that natives have those germination issues. All of that makes them quite expensive to source. And there is another anomaly here. We are paying per gram. So, for example, in grasses become quite cheap in that respect, and you can cover a lot with grass because, you know, in kilo of grass seeds, you have thousands of seeds, and then for trees, you might only end up with handful of seeds, which then artificially tilt this mix that we use. So this is a typical rehabilitation mix, at least in mining industry. The seed mixes are dominated by grasses and very little legumes, trees, and others are included. So if we look at the pre-disturbed record or something that we try to recreate, this is not what we see. In here we see trees, we see grasses, we see many herbaceous plants. So obviously what we're putting in is not representative of what's there. So that all brought us to this project. We start looking at trying to bring together those aims that I mentioned earlier, the vision for Pilbara to becoming food hub, and also these other industries, also to marry it with mine rehabilitation targets. And so in collaboration with so our University of Western Australia and Department of Biodiversity and Conservation and Attraction, we embarked on this study. So we started off with this idea that there is evidence that all these native plants that we are trying to put in while delivering land rehabilitation can have many other secondary purposes. So, so we conducted this study to find species for future establishment of native plant seeds or plant production fields to support, first of all, that rehabilitation seed supply, but also have some potentially other properties like bush food, medicine, pastoral, biomaterials, and so on in Pilbara. So our methodology, so this was just a desktop study, so we sourced some literature data, reports, publications, databases, also opinions from our project members and industry partners to summarize information about relevant plant species on their attributes. So we started off with narrowing down actually to more manageable list of species. So from all plants found in WA, about 1,200 species, we went down to native plants, and we then targeted just one site, so to make it, as I said, more manageable, and then looked for their properties in terms of seed biology, soil habitats, their uses as food, medicinal, other human use, also pasture or other animal benefits, or their role in rehabilitation and ecological benefits. We gathered all this information and then put it in a format of a database that we call NPP database. So I can't present all the results that we have in that database. I'll just give you a snapshot of what we did. So we gathered information on 125 species, and we had a good spread between herbs, trees, grasses, shrubs, also annuals and perennials. So let's have a results against these attributes that we investigated. So in terms of soils and habitats, we had a good portion, about 2/3 of candidates that can grow on a variety of soils and habitats. We also had a good distribution of all life forms and types, from annuals and perennials, herbs to trees, differing in requirements and cover a range of conditions and seasons, thus growing in different parts of landscape. So that the conclusion is we can use plants that other than grasses. However, unfortunately, we found that most of them had those seed issues. So only 12 species did not have any issues with dormancy or germination. In terms of their attribute as food, we found a good portion of candidates, 87 candidates, had edible properties, and majority of them were from acacia. And on the right, you can see some examples. Most of them were eaten as seeds, but there are other parts that were eaten. But what I'd like to mention here that many of these plants actually were found to have some good nutritive profiles and advantages, especially targeting some modern age diseases. But some plants were also found to be toxic. And there were some other uses as flavoring or food preservative. In terms of medicine, as many as 99 candidates had medicinal properties, again mostly from acacia. They were used for all sorts of cure all sorts of diseases. But one interesting thing that I have found is the use of Triodia or Spinifex, where they were using traditional use is to cast a resin. Cast resin to make to hold skull in little babies to hold their skull while bones are calcifying. In terms of other uses, we found nearly half of candidates with some other interesting uses, as for example, as new biomaterials, and they were dominated by acacia and Triodia. And I can't bypass this one. When Triodia or Spinifex made it into news, we're now extracting that resin and making new nanomaterial to make the thinnest condoms. So in terms of cropping, we found about 70 candidates with desired attributes as crops, having rapid growth, high biomass yield, or have history of being cropped. Also, or can support cropping in terms of nitrogen fixation and soil improver. Now down my alley, in terms of livestock, as many as 80 species can have attributes as grazing fodder. Again, most numerous from acacia species, and some had really nice and high grazing value. And what is also interesting in our other work, many of these actually have potential to reduce enteric methane from ruminant livestock. And finally, in terms of ecosystem service, a good range of plants had desirable properties, preventing soil erosion or windbreak, resistant to fire, all providing wildlife service as fodder or shelter. So there are a couple of them with some, there were, again, good range with multi-purpose, having attributes across these properties, mostly acacia and triodia. So this is how that database look like. Hopefully it will become public so you can search and have a look. We also generated a couple of fact sheets on the most prominent species. Again, hopefully we'll be able to release them for you to have a look. And just in summary, we found many native Pilbara plants can serve for rehabilitation seed supply, supporting ecosystem, but also many of them have obvious attributes as bush food or pastoral or for biomaterials. Future work, it's up to you now, more practical work and case studies in other parts of Australia, and hopefully we can have some more exciting results throughout. Thank you.
Fantastic, Zoe. Thank you very much for your presentation. Okay, now it's time for the interactive part of the session where we take questions from the floor. The first one's coming to you, Lee. Robin Cowley would like to know, is there any monitoring programs following the impact of changed fire regimes on fauna and flora at the park?
Good question, Robin. There is, to an extent, we have done some monitoring work. It's really tricky because one of the driving sort of aims of that program has been centred around protecting carpenter and grass wren populations, and they've got to be one of the most cryptic birds in Australia. So in that sense, it's been really hard to sort of use those as an indicator of our management, I suppose, or management success. Even though we have done surveys and found the birds persisting, it's still sort of really tricky to say anything too definitive. But we also do just have sort of annual monitoring surveys that we do across the park that are aimed at just assessing condition of the Spinifex grasslands and also those really fire-sensitive communities that I was talking about. So watching those improve in condition over time has also been a really important outcome from the program.
Okay, fantastic. Lee, Ian Houston wants to know, well, he wanted to let you know, great informative session, but he also wants to know what happened in 2018.
Oh yeah, I would have liked to have gotten to there, but I didn't. So in 2018, I think it's just something quite poignant to kind of consider with that event. So that was that sort of period of time where we had that massive heat wave across Queensland, and most of Queensland was on fire. And originally that fire sort of approached the park, and I was quite confident that it sort of couldn't go too much further, but it sort of snuck around some early burns, and then just over that period of time where I don't think sort of humidity got up over 10% for a couple of weeks, it just sort of carried across, burn scars and fuels that it had no business to. And I think that's, in the whole scheme of things, it's not a really massive scar at the end of the day, but if that's an example of what's to come under climate change forecasts and stuff, we're going to have to be really mindful of how we manage fire down the track, because that sort of really took us by surprise, that event.
Okay, a couple of questions now for Heather. Heather, Bev B wants to know whether cat predation has been a factor in limiting native species recovery in the past 24 years.
Yeah, sure. Thanks, Bev. It almost certainly is something that's going to affect small mammals and reptiles in this environment. What is really difficult is that we don't have a good way of controlling cats. But what we do know is that with the removal of grazing, if we can help the vegetation structure at the ground level to re-establish, that then provides a bit more protection from those feral predators like cats and foxes for the type of animals that we were surveying.
Fantastic. Thanks, Heather. I'm just going back to the questions now. Mine are reloading. There was a question from John Brisbane. Perhaps you can read it while mine's still loading. Oh no, here it is now. Heather, are you concerned that this will be used by graziers to say sea grazing has no impact on biodiversity?
Okay, thanks, John. No, I don't think so. What I think it's actually telling us is that heavy grazing, particularly at the casuarina sites close to watering points, can have huge impacts on biodiversity and impacts that haven't been able to recover in 25 years. Because when we look at our fauna assemblage at our casuarina sites compared to what we think should be there when we compare it to casuarina sites that haven't been, which are relatively intact, we're certainly missing a lot of those species still from our casuarina sites.
Okay, great. I will stay with you, Heather, and then I'll come back to you, Leanne. Andrew Craig is keen to know, Heather, what role does fire play in the ecosystems that you studied, and did the fire regime change when land use changed?
Yeah, that's a really good question about fire. So we actually selected sites for this particular study that all had the same fire age because we didn't want, we just wanted to focus on the grazing removal impacts for this particular study. But yes, fire, the Mallee woodland is a fire adapted system. When the place was used for sheep grazing, fire was generally excluded from the property. But what we're trying to do is actually establish fire and trying to use fire strategically to maximise outcomes for biodiversity. So one project that we're actually starting relatively soon is looking at how vegetation responds to fire, but in the context of thermal refuges for reptiles. So reptiles need to escape the heat. We know that with climate change, we're going to get hotter climate overall down here and more extreme heat events. So things like thermal refuges are going to be really important for reptiles. And so it's about trying to build some of that climate change resilience into our ecosystem here as well.
Okay, I've got a questions come through for Zoe. Zoe, there are a lot of species that seem to be good for the rehab. What are the prospects like for getting enough seed for any reseeding projects?
Yeah, so I think that's what prompted this study anyway, is that the fact that we don't have enough seeds, and the mining companies are actively seeking, and they have them in their seed banks, but there is a chronic shortage of these seeds. So the idea is that we can initially start cropping this, growing this for seeds, so we can establish on the ex-mining sites, we can establish plantations for seed supply for rehabilitation, which can become sustainable. And yeah, so one good thing about mines is that they often have access to that water, so they need to dewater their mines, and so that becomes your source of water through pivots. So it is possible, but yeah, we're still thinking about that.
Okay, thanks very much, Zoe. Just to let you know, there's also a live poll going on for this session. So if you wanted to take part in that while you're listening to the Q&A, you are most welcome to. Marie Bowen, Lee wants to know, and someone else too, because they've liked her question, the reduction in annual area of uncontrolled wildfire over time is impressive. Has there been any data collection to monitor the effects of changed fire management on biodiversity of a range of plant and animal species in the park?
No, I mean it's probably follows on a little bit from Robin's question. There were sort of probably over 10 years ago when we had some fire ecologists who sort of worked on the park quite frequently, collected some really good data around some of that work. We haven't revisited a lot of it, and it's probably a good opportunity to do that now that we're so far down the path with the program. Yeah, I mean, I sort of often fall down rabbit holes considering some of this stuff, and you know, like coming up with some sort of metric for patchiness across a landscape and what that means for biodiversity is, you know, is complicated, I suppose. But it's I know AWC with some, you know, patchiness and measuring the distances to the, you know, closest unburnt refuge and things like that. So there's certainly lots of scope for it, but yeah, at this stage of the game, it's just really promising to see that diversity across the landscape and know that biodiversity exists on all sorts of scales. So hopefully we're just providing opportunities for that biodiversity to thrive.
Fantastic. Lee, and Matthew Fletcher's just keen to know, in your presentation, the Spinifex species you were talking about. Can you just remind us what that particular species was?
Yeah, so the park has mostly pungens, Triodia pungens, and across, so those sort of softer Spinifexes and some of the ones further down in the arid zone.
Great. Question coming in now for Heather. Heather, Robin Cowley's keen to know, were the artificial waters turned off when the stock was excluded? And what is the feral predator impacts at the site? Were they looked at too?
Yeah, so feral predators, as I mentioned before, in response to Bev, are certainly something that's going to be impacting fauna assemblages. We don't, we don't have a great way of controlling cats, but we do do regular fox baiting. It is also quite difficult to actually quantify fox and cat densities across these areas as well. So feral predators certainly have an impact, but whether or not we exactly know how much of an impact is a knowledge gap that we are trying to address. In terms of the watering points, so we still had functional dams, and we still do have some functional pastoral dams on the property. And so the past sort of 10 years has been a process of actually decommissioning those dams and making sure that that surface water is no longer being held in those dams.
Okay, fantastic. Leanne, we're going to come back to you now. Terry B would like to know, to what extent does fire management on Bujamala reflect wider burning on parks now and possibly in the future?
Mm-hmm. The short answer is probably that it just depends. There's certainly active fire management on most national parks across Queensland, but depending on where they are and what their sort of requirements are in terms of burning, it changes. So, you know, as an example, Cape York is, you know, sort of more tropical and highly productive sort of savannas that you know are burnt quite frequently. But when you come down around here, around the Channel Country, some of our protected estate down here doesn't quite have the same sort of fire requirements. And then you go across to southeast Queensland, which is trickier again, where you know, I don't envy my colleagues who manage those parks around Noosa and places where they've got that really, you know, strong sort of interface there with urban development and you know, airports and all sorts of complicated things. So in short, you know, most parks do and should have some sort of active fire across, but it really just does depend on where they sit in the landscape.
Okay, and a detailed question for you, Leanne, while you're in key, you know, while everyone's keen to ask
in the hot seat.
In the hot seat, my goodness, that's what I was trying to think of. I'm starting to they need to wind me up again, I think, after 2 days. Andrew Craig wants to know, with your mosaic burning, do you carry it out from the air or the ground or both?
Mm-hmm. Mostly it's aerial incendiary. So usually it's from a R44 helicopter or a fixed wing. But we do some ground burning around sort of Lawn Hill Gorge and some of the sort of accessible parts of the park. I sort of didn't get into it too much, but most of the park is quite inaccessible. So it's quite interesting when people talk about fire breaks. We don't. They sort of don't even really have any place on a park like Bujamala, because we use those early burns as our fire breaks. So there's very few areas where we sort of intensively manage on the ground, because we generally don't need to. I'm glad I'm doing this just before the fire season really kicks off out there, just in case I get caught out. But yeah.
Fantastic, thanks, Lee. Look, we do have a couple more questions for Heather in the list, and one for you too, Lee. But what I'll ask you ladies to do is if you could use the pencil icon and just type a brief answer to those questions that we haven't had a chance to get to. Our camera stream is about to be cut off, and so that wraps up this session. Thank you so much, Zoe, Heather and Lee, for making yourselves available this afternoon.
Thank you.
Thank you.
Yes, thanks.
Can you ladies see this?